With problem number 6, we see a radical, and we don't really want the radical there right now because we know we have to antiderive, and rational exponents are much better for that. So therefore, we're going to need to rewrite this antiderivative of 7x, and then we're going to have square root, not square root, that's not going to be there anymore, my bad. We're going to have 5 minus x squared to the 1/2 power dx. Okay, so how do we go about this? Well, what do you think the inner function is going to be? Yeah, hopefully you pick 5 minus x squared. So u is equal to 5 minus x squared, and the derivative of that will be negative 2x dx. Alright, so we have the dx, we have the x, but we have a 7, and we want a negative 2. Now you can go about this one of two ways. Alright, you can realize that 7 times negative 2/7 will give us the negative 2 that we're looking for. Or what we can also do is say, well, this 7 is a coefficient, so that can move out front. Right, so that we have the 7 out here, and it's no longer there. Okay. The negative 2, we want that to come in, so we're going to put a negative 2 here. So now we have the negative 2x that we're looking for. I guess technically I should put it there as well. Okay, but if we put a negative 2 on the inside, then we need a negative 1/2 on the outside. And 7 times negative 1/2 is negative 7/2. So that's another, one way or another, you want to end up with negative 7/2 on the outside. And again, you can do it the way that I just showed you, or you can say, well, I have a 7 here, I need a negative 2, 7 times negative 2/7 gives me the negative 2, and if I put negative 2/7 on the inside, then I need negative 7/2 on the outside. All right, but the key is that we end up with negative 2x dx on the inside, and negative 7/2 on the outside. So negative 7/2 is there. The negative 2 and the x and the dx, they are all out, and du is going to come in. And we have 5 minus x squared to the 1/2, but u is equal to 5 minus x squared, so this will now be u to the 1/2. And u to the 1/2 antiderives to u to the 3/2 over 3/2 plus c. Now when we're dividing by 3/2, that's the same thing as multiplying by 2/3. So we can have the negative 7 over 2 times 2/3 times u to the 3/2 plus c. And those 2's will actually cross out. That leaves us with negative 7 over 3. And again, we don't want our answer in terms of u. We'd like it in terms of x. So u is equal to 5 minus x squared. So we'll have 5 minus x squared to the 3/2 plus c. It's a much more complicated antiderivative, mostly because of this whole changing of the coefficient part. And then also with the dividing by 3/2. Again, there's nothing wrong with this. If we just replace u with x right at that point, that would be correct. Just looking to remind everybody of their arithmetic skills, just in case you see this as one of the options on the exam. All right, number 7. We have the antiderivative of the quantity 4x minus 1 to the 6th power. So, just like problem number 4, we see that we have a fraction, and when that's the case, we tend to make u equal to the inner function of the denominator. So u is going to be 4x minus 1, and the derivative of 4x minus 1 is just 4. So we'll have 4 dx. And we see the dx, but we don't see the 4, so we can quickly toss the 4 in, but we have to counterbalance it with the 1/4 on the outside. 4 times a quarter is 1, which means we did not change the value of our expression there. All right. Now we can do our substitution. So we have the antiderivative with 1/4 out front. The dx is combined with the 4 and turns into du. And then we have 4x minus 1 to the 6th power, but now u is 4x minus 1, so this will be u to the 6th power in our denominator. Okay, now this is not the natural log of u to the 6th. We have to be careful here. Students look at problem number 4 and say that's a natural log problem, and therefore problem number 7 must also be a natural log. But this is not u all by itself in the denominator. It's u to the 6th power, which means that we can rewrite this with no longer having a fraction. Section that off there. U to the 6th, a positive 6 in the denominator, becomes a negative 6 in the numerator. All right, we can do this with problem number 4 as well, but that leaves us with a negative 1, and that also sends us to natural log. But this is not natural log. This, with our 1/4 out front, the antiderivative of u to the negative 6 is u to the negative 5 over negative 5, all right, plus c. So what we end up having here is 4x minus 1 to the negative 5 over negative 20 plus c. And you can write your answer like that, or just be aware that this is also equal to, let's move our negative sign up front, negative 1 over 20 times the quantity 4x minus 1 to the 5th. The 5 can become positive if it moves down into the denominator. This answer is good, that answer is good.